So we're going to switch gears a little bit. We were talking about infrastructure as a service, and in the last section, talking about Kubernetes containers. In this section, we're going to be talking about web apps. Now, web apps have a lot in common with containers. Essentially, you're going to create and package your code on your local machine, and then you're going to publish that code or upload that code into your web app service. And Microsoft Azure is going to take care of running the web app. It's in control of the infrastructure. You do not have remote access into that. There's no SSH or RDP into a web app. And in fact, you don't have a lot of insights into the hardware itself. Now, you should keep in mind that Microsoft is probably sharing the hardware between yourself and other clients in a tenant scenario. And so there's a reason why you don't have access to the underlying stuff of web apps. There is an isolated version of web apps, and we'll talk about that coming up in this video. Now, Azure web apps are sometimes called Azure App Services. When you're using either term, you're basically referring to the same thing. Sometimes people will talk about API apps or mobile apps. Well, those are also app services, and in fact, there's no perceivable difference between a web app, a mobile app, and an API app. So those are all the same thing. They have different names and different icons, but they're all Azure App Services. There's also the ability to run Azure Functions as a web app or inside of an app service. So besides the web app, mobile app, and API app, you also have a type of function that can run. Now, functions are also a serverless model, so when you're setting up your functions, you can choose between them. But we're going to talk about app service model in this section. Now, web apps are a little bit different than containers in that they only support a set of languages. So for instance, the Azure App Service supports .NET, the classic, .NET Core, which is their new open source version of .NET, Java, Ruby, Node.js, PHP, or Python. If you need applications that do not are not any of these, you're probably going to have to use infrastructure as a service so that you can control the environment. Okay. Now, there is going to be a difference between choosing Windows web apps and Linux web apps. For instance, Linux web apps do not support .NET Classic. They only support .NET Core for obvious reasons. Let's switch over to the interface, and we can go through the process of creating a web app and demonstrate this. Now, on the Azure portal, you can go up to the Create a Resource, the green plus, and hit it. And you'll see web apps listed as one of the most popular options. It's right now number 3 on that screen that comes up from when you put the plus sign. You can also find them under the web option, and you can see their web apps for containers, logic apps, and API apps, and etc. Like I mentioned earlier, API app is just a web app with a different name and a different icon. So let's choose web app. Now, web apps are public by default, and so they're going to be given a fully qualified domain name, and whatever name you choose has to be unique across all of Azure. So this AZ-SJD new app that I chose is unique across all of Azure. Now, don't worry about this if you don't like this URL. You can always register your own domain name in the traditional way and use the domain name service to map that domain into the web app, and we'll look in the settings of this app service on how to set up a custom domain name. You choose your subscription. Now, everyone's subscription might be a little different. You might have the free plan, you might have the enterprise plan, or your company has its own unique plan, MSDN accounts, etc. So mine's the pay-as-you-go option. I'm going to create the resources for this web app in its own resource group. I like to separate out things, makes it easier to delete after and to clean up. Now, this is where I said we have the option between operating systems. For Windows, you can see that it supports application insights. If I switch over to Linux, it does not, and in fact, Linux forces you to choose the underlying runtime stack as part of this, okay, part of setting up the service. For Windows, you don't have to make that choice. You can upload different types of apps, and you can deal with that in the settings. Application Insights, the reason why that's Windows only is because it allows you to surface data that only your application might know to the portal for other purposes. So this ties in with your application using an SDK, and you can basically get your application to report back to the portal on specific information, and then you can monitor on that, trigger on that, or use that for scaling purposes, etc. So we're going to create a classic Windows operating system web app, and we do have the choice between code, which means that we're going to develop it using a tool such as Visual Studio or Visual Code, and then we're going to publish that or upload that into the application directly. Docker image, very similar to what we were dealing with the Kubernetes service. That means that you're going to push this to a Docker Hub or ACR, and we can then do deployments based on Docker images, not based on direct code being pushed. Now, this concept of the app service plan, perhaps this is a pretty important concept. The app service plan is very similar to a hosting plan. So just like when you want to set up your own website, you go to a hosting company and then you sign up for a service. They have different tiers and different options depending on how much you want to pay. Microsoft Azure has this hosting plan. Now you can have multiple web apps running in the same hosting plan. To understand the different pricing options, we can go to the Microsoft website again, and we can see the different options. We haven't got into it yet, but I'll talk about them in a second. But we can see that there are some limitations to the number of apps. There are 10 limit on the free plan and 100 limit on the shared plan. But after that, you can actually deploy an unlimited number of applications into the same app service plan, subject to the other limits. So subject to the disk-based limit, or subject to basically those apps needing performance compared to the other apps in the same plan. Okay, so 10, 100, and then unlimited after that. Let's go back to here. We're going to create a brand new app service plan for this web app, and I'm going to call it AZSJD new plan. Now this name does not need to be unique across all of Azure, but it does need to be unique in terms of your region, and I obviously have an app service plan with the same name in the central US region, so I'm going to call it 2 Classic. But I don't even want to put it in central US region. I'm going to put this host into the East US region. The implication of choosing the location essentially is performance related. Your app should be closest to the users who are going to use it to reduce the latency, the amount of distance that the data has to travel between the users and the application. If your application is global, then you want to choose a location that makes sense to you. Now let's look at the different tiers. Now I already alluded in the pricing to the fact that there are free, shared, and other tiers. So Microsoft splits this out between dev, test, production, and isolated as the 3 major categories. And under there are many different pricing tiers. Okay, we got the F tier, the D tier, the B tier, and so on. We're going to pause the video, and in the next video we're going to review each of the options for the pricing tiers. Alright, so let's talk about the app service plan tiers. At the lowest end of the tier is the free shared option. Okay, it's called F1 here in the app service plan screen. And we can see that it's free, which is the awesome part. That means you can deploy code into a free host, and basically it's accessible on the internet. You get 60 minutes a day of CPU time, so hopefully what you're deploying is not too popular. But I've deployed WordPress websites into this before, and certainly you can fit a lot into 1 gigabyte of memory and 60 minutes a day of CPU time. Now there are no bonuses here, there's no features. You really only get the 1 gig of memory and 60 minutes a day of compute. This is great for the initial setup of something. If you're not sure what you're going to end up doing, you might want to start dealing with some of the SSL certificates and um, the other options, the custom domain names that you get from higher level plans, even in development. But for early on in development, you might just want to fire up a free option. And remember, you do get the limit of 10 apps, but for if it's free, that doesn't matter if you create multiple app service plans at that point, right? Now, next level up is the shared D1 plan. Okay, so basically you're still running on a limit of 4 hours a day. So it's basically 1/8 of a CPU that you have access to. Okay, you get the same 1 GB of memory. At the shared plan, you do get the option of having a custom domain name. So this starts to be a little bit useful at that point. The first tier that really has any um, usefulness at all really is the basic tier. Now you are starting to pay for this. I think it's $70 a month, $140 a month, $280 a month. You get SSL certificates, or you can use them, custom domain names, and you have the ability to scale. So if your application has some performance issues and you want to add more copies of your web app, well, then it's very easy to scale up to an additional instance. Microsoft takes care of the load balancing for you and is basically seamless to your users to basically scale up to a higher level. Now these are all labeled under dev test, so Microsoft does not suggest this be used for production workloads, or even if it is used for production workloads, it has to be less demanding workloads. When we get into the basic option, we start to talk about this concept of Azure Compute Units, or ACU. So the B1 plan is 100 of this ACU. Now what's an ACU? An ACU is just a number that Microsoft has come up with to express the performance that is only useful when comparing with other plans. So we know the B1 is 100 ACUs and the B2 is 200 ACUs. So we can say that the B2 plan is twice as performant as the B1 plan. We should expect a double of the equivalent CPU performance. They do give this suggestion that it is a A-series equivalent. So if you're unfamiliar with the virtual machines, then this is an A-series equivalent. It may or may not be an A-series, but that's what they're setting your expectation. Pricing is roughly double. When you double performance, you basically double the price on the same tier. So to go from B1 to B2 is almost exactly double. And you get double the performance, and to go to B3 is almost exactly double, and you get double the performance. Same holds true at the higher levels. Now when we switch up to the production level, then we start to see what Microsoft does recommend for most production workloads. You have standard and premium. There are 3 standard plans and 6 premium plans, although the premium plans are divided into P1 and P1 V2, which is obviously version 2 of the premium service. Now we can look at the features for standard. We not only get the custom domains in SSL, but we get auto scaling. So this is the first tier that supports automatic scaling up and scaling down, does not require you to write scripts or to be manually monitoring the performance of the application. We also get staging slots, which we'll talk about. These are helpful when you're developing and you want to do some testing, etc. for QA staging. We've got backup options at this level, and we've got a load balancer that runs on a global scale called Traffic Manager. So you get, this is really some pretty good features that you're getting. Okay. Now when you move up to the premium plan, what's the difference between a standard and a premium? Okay. Now, basically, you're going to get more of each. So on the standard plan, you get up to 5 auto-scale instances. On the premium plan, you get up to 20 instances. So if you really do need to grow the performance, then you can enjoy up to 20 instances of this. Staging slots up to 20, although I don't know who's using 20 staging slots. That just means 20 different versions of your application that is available to be tested. But the feature is there. Daily backups. So at the standard level, I believe it's 10 times a day backups. That's once every 2 hours roughly. And if you go up to the premium option, then you have up to 50 backups, which is every half an hour roughly. So it's 4 times, 5 times as many backups exactly, right? So that's the primary difference between standard and premium. When we look at the Premium 1 versus Premium V2, what is really interesting, to me at least, is that the Premium V2 is a lot cheaper than the Premium 1, and you get twice the performance and twice the memory. So to save $90 a month, you get an extra 110 ACUs and you double the memory. So it would really be interesting to understand why you would need Premium 1 if you're not going to choose Premium V2. This is like savings built into it right there and double the performance. If we compare the P2 that has 200 ACUs with the P1 that has 200 ACUs, the price difference is pretty stark, $300 a month roughly. The other thing you can compare is the standard plan. If you look at the standard 2 and the Premium 1 V2, same level of performance, same memory, same price. So again, why would you choose standard when premium has more features and is exactly the same price? So really this screen is setting you up to choose the P1 V2 or P2 V2 or P3 V2 options, and all of the other options don't make sense compared to them. So after all of that, options in your own workloads within your own environments or even on the test, I would not suggest choosing anything other than P1 V2. Now, there might be questions around what do you get in the premium tier. So if you need more than 10 backups a day, then you're forced to go premium. But we can see here the pricing really doesn't make sense between S2 and P1 V2 or P1. Moving up to the isolated plan, the name kind of gives it away, but if you do not want any other users or tenants running on the same hardware, then you have the option of signing up for this isolated plan. This is like a combination of virtual machines, infrastructure as a service, and platform as a service. You get all the benefits of platform as a service, how easy it is to deploy, all of the built-in backups and auto scaling and all that stuff, but you're running on your own hardware, on your own network. Okay, so there's no traffic to slow you down. There's no other tenants running on that computer to slow you down. The pricing, of course, really makes up for it. So when we go from P1 V2, $190 a month, to I1, it is $280 a month, which is 50% more. But you might think, oh, 50% more, that's reasonable for your own hardware. This is not entirely accurate because there's a $1,000 a month charge for the hardware. So you're paying $1,000 a month to have the single tenant, plus you're paying $285 a month per app service plan running on that tenant. So then suddenly things start to click. Okay. So unfortunately, this screen, I would hope Microsoft would put an asterisk or sort of put the thing, but there is a $1,000 a month charge on top of choosing one of these plans. The reason why it doesn't say $1,285, I guess, is because if you have multiple instances, so if you have your I1 plan and you want to have 10 running instances of I1, then it's going to be 10 times 285 plus 1,000. That's how the pricing works. So that's how those are the differences between the different plans. Sometimes this change, I would go back from time to time and check it. For the purpose of this demo, I'm going to follow my own advice. I'm going to choose the P1 V2 option because again, well, actually I'll choose the S1 option because it's half the price. I'm going to choose the S1 option, and we can show you later on how to switch between them. So I'm going to click OK, And what we now have is a web app running on Windows that I'm going to expect to push code to, brand new app service plan, and application insights has turned itself on for this as well. When I click create, this is going to create me an empty web app. I'm going to do that, and in the next video we'll see how that worked. So creation of this web app actually went by pretty quick. We can see in the resource group that 3 resources got created. There's the actual app service, there's the app service plan, which we gave a name to, and the application insights object as well. So there are 3 resources inside of our resource group. If we go up to here where it says deployments, one succeeded, we can actually look at that deployment. It took 53 seconds to create that. So it's actually pretty quick, relatively, to get a new web app created if you ever needed to do that. So now this web app is up and running, but at the current time there's no code in there. We haven't actually written any code, we're not deployed any code. So what do you think is going to happen when we go to the URL? So I'm going to click on this, and we're going to see that Microsoft has basically a standby web page that says your app service is up and running. Okay, so basically this is a Microsoft page that tells us everything's working. When we deploy our app service, our web app into here, it's obviously going to go away and be replaced with whatever we have. We can see that our standard S1 plan did get created and it is set to be running. We do have even the option to FTP up our code, so we can use the FTP deployment username to the particular URLs being provided if we wanted to deploy that way. But like I said, Microsoft Visual Studio actually makes it pretty easy to deploy into a web app, and we'll demo that in a second. Now, I did mention a few things. The custom domains, if we do want to create our own custom domain, we can go down here into custom domains. There is the option of setting it to HTTPS only. We can add the host name for our custom domain down here. And our app service domains, we can actually buy the domain here as well. Some of the plans come up with backup options, and so we can set up our regular backups into the backup section. Now, we made some decisions when we were setting this up, but we didn't make a lot of decisions. Microsoft has basically hidden most of the settings for the web app into the application settings tab. We can see here Microsoft is telling us which applications it supports. By default, .NET Framework and PHP are turned on. And we can see that it's 4.7 in the version number and 5.6 for PHP. If we wanted to use a Python or Java app, we actually have to go into the app settings to enable those. One of the principles of security is to turn off things that you're not using, and so having Java enabled but never used would be a site security risk. So it's turned off by default, and you can see the Python is turned off by default as well. We have all sorts of options. This is going to be very similar. If you're familiar with setting up IIS, then you're going to see a lot of the same options here. We get 32 and 64-bit decisions, always on. And so if we want our web app to always be responsive instantly as opposed to having to spin up, the integrated and classic options in terms of pipelines, if your application requires one or the other. You can set HTTP version, session affinity, so this is if you support cookies and having the cookie drive the same user to the same server. We haven't talked about deployment slots too much, and how the FTP based deployments work. We can actually disable that if we don't intend to use it. So we have a lot of options. They're all in the application settings set here. All right, so we've got a basic web app going. There's no code deployed to it. Let's continue on. So we've seen up till now that web jobs are basically websites. You package and upload the code into Azure, and Azure will run that within your app service plan. Now, it does take a viewer visiting the URL in order for the website to run. So if you upload code into your web app, but no one ever visits the URL, that code will never run. Now, there are options for running background processes, which means it can run independently whether somebody visits or not. Those are called web jobs. Web jobs are a feature of web apps. And what that means is that you require a web app in order to create a web job. So if I go into the menu and I click web job, you'll see that this web app has no web jobs currently associated with it. Web jobs provide an easy way to run scripts or programs as background processes. And it runs in the same context as the website as well. So basically, web jobs are a background process. You can give it a name. I'm going to call it web job. You choose the script or program to run. And I'm going to choose a PowerShell file that I have. It's a very simple program that just outputs hello world. And I have to choose whether this is just going to continuously be running. So is it a program that will start up with the web app, and then as long as the program runs in a loop, then it'll just never finish? Or is it a program that starts and stops and will be triggered by something? The triggers in this case are a schedule or a URL, which is a webhook. Okay, so I can say this job will run based on a cron expression. Now, cron is a language or an expression, a syntax that is usually used. I believe it started in the Unix or Linux world, and you basically give the expression of a cron expression. It'll tell it what kind of schedule to run at. So you should be able to go to your favorite search engine and search for cron expression generator, and it will make it a lot easier for you to generate this cron syntax. For instance, I want this hello world to run every hour. So as soon as I create this web job, it should execute at the top of the hour every single hour. You can see that the resulting cron expression looks something like this: 0, 0, star, 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 star. It does break down in this particular cron generator what those numbers mean. The seconds equal 0, the minutes equal 0, every hour. Now, I don't believe Azure supports the question mark format, so I'm going to put star here, but every hour, every day of the month, every day of the week, every year. So I'm going to copy this, and I'm going to paste it into here, and it tells you an error message. I get to replace that with this asterisk. And basically we can see, I guess it doesn't support the day of the month and the day of the year kind of thing. So 0, 0, star, 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 star means 0 minutes, 0 seconds, 0 minutes, and every hour. And this job will run every hour. So you can figure out the cron format, I guess. So if I was to say OK to this, it will add this triggered web job to my web app, and it will run every hour forever. Okay. Now, web jobs don't have user interfaces by default, and so having it say hello world, I can show you my fancy little script here. It just says write output hello world. Having that will actually not result in anything because background jobs are background jobs. But if this was a PS PowerShell file and you wanted it to do something, to interact with Azure, to move stuff in files, to do actual work, this would be a background job. It could run every hour. Okay, so that's the basics of web jobs. It does support scripts and programs, and so you can just upload it. It supports multiple, so you aren't limited to a single thing, but this is how you do background scripts within the platform as a service model. So another requirement having to do with web apps for this exam has to do with enable diagnostics logging. Now we can see right off the top, the first thing on the web app overview is a link to how to diagnose and solve problems. Now ultimately, this is a link to basically documentation and stuff like that. What you want to do is go down all the way to almost to the bottom of the settings. There is a monitoring section. And in here we can set alerts. So if you want to be notified when your application's having particular issues with high CPU, there's also the ability to run metrics. So you can basically graph CPU usage over a period, or data usage, HTTP errors. We can see if there were any 404 errors thrown by the app, etc. We can make these charts and basically pin them to the dashboard, or we can even create an alert based off of one of these items. But it's important to know your application runs just like any application in IIS. That is, it can create log files. So right now, by default, I turned off all logging, and there's no logging going on for this app. Now, not that we've deployed any code to it yet, except for the web job, but you can see here, it's not saving any log files, right? So I might want to start off by turning on application logs. Now, application logs require a storage account. In this instance, I can obviously have it stored to the local file system of the web app as well, or I can have an external storage account. I'll have to configure that. So I'll create a new storage account really quick here. So I'm going to call this app logs. Oh, it's oops. Well, I did that. So it's a fully qualified name, .core.windows.net. Call it app logs. V1, standard performance, locally redundant storage. There's nothing, we don't need to have this being globally available, etc. So click OK. And when that's ready, then we'll be able to turn on application logging for this web app. So the storage account got created. I get to select it. I do have to create a container, and this is for web app logs. Private access level, makes sense. So I'm going to select that container. And now when I save this, my web app will start spitting out its application errors into a storage account. I can also choose the number of days to store, so it can become a rolling system. Now we also have other types of error messages: failed request tracking, detailed error messages, web server logging, etc. So more than just the app logging, we can do it like IIS logs essentially. So if I go into the same storage account, I can create called it web logs. Select. So when I click save now, I have to pick the retention period for the web logs as well. Bang, enough. So now I'm storing the logs that the application would throw, so any kind of events, errors, exceptions that were not handled, and IIS itself, how it would have logs. So all of the, even if an image is retrieved, and all of the HTTP requests get stored in here. Okay. Now we would have these things in a diagnostics log. So how do we then view these logs, right? So now we start collecting the logs, but how do we view them? Well, first of all, the logs are being stored in a storage account, and so in a blob, and you can basically access the contents of that blob container at any time. So for instance, if we were to go to my all resources here, and I was to look for storage accounts, we created the app log storage account. We saw there's blob table. I'm going to minimize this. I can go into web logs, And I can see that just like we would expect with something like IIS, the web logs are broken into the name of the app, the year, the month, the date, the time, and there is a small log file that's been created. Okay. So if we wanted to download this, we can download this to our local, and we would have access to the contents of this log file. The other thing that we can do is go into the web app, and there is a real-time log stream. So if we're in the process of testing, then we'll be able to see real-time interactions with our website within the stream. Now, the application logs that they're talking about here are not the storage account ones. They are, in fact, the file system ones. So we can see with this hover, it says you'll need to turn this on to enable the streaming log feature. The setting turns itself off after 12 hours. So this is a temporary storage for logs, and then you can basically use the streaming feature with this application log setting. So we'll give that a second for the application to kick in. But if we go back to streaming logs, we can now see a console start up, and we're now connected to the log streaming service.